Hey everybody, and welcome back to Algebra 2 Online. So in this video, we're just going to be doing some more just trig equations, and all of them are kind of on the harder side of things. You're going to have to use some trig identities, simplify things, and stuff like that. So this first one just wants to find the principal root of sine x over cos x plus cos x over 1 plus sine x equals 1. So this thing, you definitely want to try to simplify that, right? You don't want to try to start thinking like, how to solve for x unless this thing can maybe be simplified. So two fractions, always should think like, let's try to consolidate that into one term, get a common denominator. So this fraction needs 1 plus sine x on top and bottom, and this one needs cos x on top and bottom. So we're going to have sine x times 1 plus sine x, and then our common denominator, cos x plus 1 plus sine x, and then we'll have cos squared x over 1 plus sine x times cos x. Multiplying the top there a little bit, we can distribute, get sine squared x plus sine x. Let's just combine our fractions too. So we got 1 plus sine x times cos x. Trig identities here. Sine squared plus cosine squared equals 1. So we actually have a 1 plus sine x up here, but we also have a 1 plus sine x here. So basically this and this will cancel, giving me 1 over cos x. But 1 over cos x, right, is just secant of x, yes. And so secant of x is what we want to equal 1. So honestly, in retrospect here, I think it might be easier. So we have 1 over cosine x needs to equal 1, right? This one is this one. And it's probably, honestly, easier to just think about this if you just, multiply this side by a -1 and not multiply by -1. You take the reciprocal of both sides, right? Then those two should still be equal. So the reciprocal of 1 over cosine is cosine, and the reciprocal of 1 is just 1. And it's probably easier to think about the answer that way, I think. So now, honestly, it's just finger trick stuff or just unit circle. You want to think, okay, when does the, for cosine, it's the x value. So when does the x value in this unit circle equal 1? Well, only over here at 0. And so we get, let's just do this in blue. We get x equals 0. That would be like the first root, the principal root for this thing. And you should definitely check the domain stuff again, like make sure that if you plug in x equals 0 here, you don't get some weird undefined thing. Cosine of 0 is 1, we just did that here. That's going to be fine, and 1 plus sine of 0 is 0, sine of 0 is 0, so 1 plus 0 is just 1. So there's no like domain issues or anything, so this thing like checks out, and it's good. So that's just the first root. Again, like if the question had asked for, all the roots, you'd have to like keep, going around and around and around the circle like that. But that is how you'd go about solving that trig equation. All right. This one is just a double angle sine 2x one. And again, you don't have to remember these trig identities. I will give you all these. You're going to just have these basically whenever you need them. You just got to know to use them sometimes. So, I would definitely try to simplify this side before I go and solve anything. Sine 2x, right, is the only thing you can do is write that as 2 sine x cos x. So this part is 2 sine x cos x. We're multiplying by a secant. A cosecant, and then it equals -√3. Cosecant is 1 over sine, right? So this is nice because the sine and the cosecant then will cancel. And so we're going to get 2 cosine x equals negative root 3. But that's the same as just cosine of x equals negative root 3 over 2. And now we're back to a nice thing that we can solve. So, thinking kind of unit circle stuff, all students take calc. Can't be in these two quadrants because it's negative. And we want to find all solutions here. So, you're kind of thinking second and third quadrants. And then you're just doing finger trick stuff. Cosine, square root of fingers above. And so, you're taking square root of 3 fingers above. That means, and you divide by 2, that means that the angle in here, the little reference angles, are basically 30 degrees, or just pi over 6s. So one of them, if this is a little pi over 6, but then this would be 5 pi over 6. And then you'd have to add 2 pi n again. And then the other one, right, you can go 6 pi over 6 plus another pi over 6, that's 7 pi over 6 plus another 2 pi n. And those would be the answers to this thing. Any, multiple of these would solve this thing. You do want to check domain again. The only fraction I really have here is 1 over sine. And, sine is only equal to 0 when the y value is equal to 0. Things on the x-axis. And so, 180 or 0, multiples of those, that's where sine is going to equal 0, but we don't have, that in here. So this truly is the solution. All right. So this one just wants you to find cosine 2x plus cos x equals 0. Solve that on the first lap, right? Whenever we write that interval, we're just thinking, x runs from 0, which is right here, all the way right up until about 2 pi, like infinitely close to 2 pi, but that gives you like this full circle here. So you do need to use an identity to simplify that. So if I go back here, this is the one where you have choice on how to do this. And it's very similar to one of those last problems, or just one of those problems in the last video, where we also had choice on this one, and we chose this because then you can get like a quadratic trig equation. And that's exactly what I'm going to do here. So I'm going to just write cosine 2x as 2 cosine squared minus 1. So 2 cosine squared x minus 1. And then we got a plus cosine x, and it all equals 0. So notice just this part is just that part, which equals cosine 2x, right? Or 2 theta, whatever your variable is. And then it's just a like a u sub thing, maybe I'll write it this way just to make it look a little more nice. It's the kind of thing we want to let the u equal cosine of x, right? So you're really solving 2u squared plus u minus 1 equals 0. This one is another nice quadratic. It's going to factor into 2u minus 1 and then u plus 1. So u is equal to 1/2 and u is equal to negative 1. Then you go ahead and you just unsubstitute. So cosine of x is equal to 1/2. If you think, actually, if we just kind of take this circle over here, all students take calc. Can't be here, can't be here, because it's equal to a positive number. And then you're just thinking, triangles in here. And you're just using the finger trick. You want to do square root of the fingers above over 2. And so the only time you're going to get one finger above is if you're at like your 60 degree. And so we can do this 1 in degrees. So x is equal to 60. And then we want the answer in the 0 to 2 pi, so we don't want to just say minus 60, even though minus 60 is a solution. We want to be at 300, right? So the other one for this one would be 300. So those two are going to be good. And then we'll do this. So we need cosine of x also equal -1. And if you're just thinking x values, right, the only time you have an x value in the first lap is over here at 180, right? So x equals 180 is the answer for that one. And so you don't need to really check anything because you don't have any like rational functions going on. You're not dividing by 0 or something like that. So you get 3 solutions in one lap of the circle. And make sure that you don't put minus 60 here for the 300 because we wanted the answers between 0 and 2 pi. And honestly also because this was in 0 to 2 pi, it's probably good to put radians because they're kind of asking for radians. Just to kind of convert really quick. That one is pi. This one is 2 pi over 3. And then the last one would be 5 pi over 3. Because if you had 6 pi over 3, it'd be 2 pi. And we're going back 1 pi over 3. So if you did want them in radians, those are the answers in radians. All right. Very similar problem now, but we're going to switch the cosines in the last problem to sines. Okay. So we're going to solve sine 2x minus sine x equals 0. You got to use trig identity for this. That's going to be 2 sine x cos x. And then we got minus sine x equals 0, right? Anytime in math you ever see the same thing in 2 terms, I would take it out. So you've got sine x, and then you got 2 cos x minus 1, right, equals 0. And really no need for u subs or anything here. You basically have one way to get this to equal 0, and that's if sine of x equals 0. And you have another over here if 2 cos x minus 1 equals 0, or cos x equals a half, right? And so we wanted all solutions to this one. So sine of x equals 0, that's just where the y value is 0, right, which is on the x-axis. So you can get an answer here, or you can rotate, get an answer there, or you can rotate again, get an answer here, rotate, rotate. So basically you're going to get 0 plus 2 pi n, or you're going to get pi plus 2 pi n. So those ones will work for the that piece of it. And then for this one, I think we actually just did that one over here, right? So we have these 2 angles that we need to work with. So 2 pi over 3 or 5 pi over 3. But since it is one where they're asking for all of them, you just add the multiplier on 2 pi. So, and the same way, I got these 2 answers over here. You're just do the exact same thing, right? Same problem. So that's just another one. All of a sudden, if you just change the cos to sine, you get something kind of different, but almost kind of an easier problem because you don't have to do the u sub stuff. You only really need to do u sub because you get this quadratic here. But here you can just go ahead and just factor it and solve each factor out. All right, one more I want to do, and this one's kind of tricky. It's definitely like getting into like bonus level difficulty for these trig equations. And you'll notice that there's sine 3x in this problem. So we will deal with that when we get to it, but I'm going to show you kind of how you can deal with other numbers in there, because if it's the double angle ones, you can just go to here and you can use these things. But if it's 3 theta or 4 theta or something, well, 4 theta is 2 2 thetas, And so, maybe really quickly I'll kind of talk about that. If we had sine 4 theta, right, that's the same thing as sine of 2 times 2 theta, right? So if you use like this identity, it should then be 2 sine 2 theta cos 2 theta, right? And then you could do things like, well, sine 2 theta is 2 sine theta cos theta, right? And cos theta, you could do all sorts of things, right? You could pick any of those, and you could put them in here. So if they're even multiples, there's actually another way you can simplify it. But if it's odd multiples, like we have over here, you actually need to do something else, okay? All right, so there's a few tricky things about this one. One of the first things is definitely that fact that we have 3x in there and not like 2x or 4x or something we could deal with. So that is going to be part of it, but the other part is that we've got a sine and a cosine, and I want to get it so it's like the same trig function. Like here I have sines, right? Here I have cosines. Here I can simplify down to just one trig function, but I want to get the same trig function, and it's a little hard to maybe see how to do this. And one thing, though, that we know is that like if we have squared trig functions, like 1 minus sine squared is cosine squared, and so we can kind of utilize that to help us here. So, and so basically what I'm going to do is I'm going to move just like this over, and then I'm going to square both sides. So I'm going to have 3 root 3 sine 3x equals 3 root 3 plus 3 cos 3x. And then literally if I go ahead and just square both sides, right, I'll get 3 root 3 sine squared 3x. And then if I square out the right side, I'll have 9 cosine squared 3x plus 18 root 3 cos 3x plus 27. And, it looked like it got a little bit messier, but it's about to get nicer because sine squared, 1 minus sine squared is cosine squared, or sine squared is 1 minus cosine squared, right? And so I can sub that in and then have everything be in terms of cosines at most, right? So what I'm going to do is I'm going to use that Pythagorean identity, and I'm just going to put literally, instead of sine squared 3x, I'm going to put 1 minus cosine squared 3x. And then just copy the rest of this down. And then you can distribute. And copy down the rest of that. Now, if you look at what we got going on, some stuff is going to cancel, but I just noticed I never squared this. I squared the sine, but I didn't square that, right? And so let me change this to what it should be, right? If you square 3 root 3, you get 27. So that should be a 27, that should be a 27, that should be a 27, and I distributed right there, so that should be a 27. Everything here is, some multiple of 9, right? And so I could actually divide by 9, and it would be a little simpler. So I'm going to divide everything here by 9. I also have a 27 on both sides, so you can cancel, honestly, 27 if you want to. But then you can go ahead and just divide everything by 9, and so we'll get the following. And then it makes sense to move everything to one side. So if I move 3 cosine squared 3x's over, I'll have 4 cosine squared 3x's on that side, and then I have 2 root 3 cosine 3x's. And then, finally, it's in a point where we can factor things. So we can take a cosine 3x out, right? And we're just going to have 4 cosine 3x from that first term. and then we're going to have 2 root 3 from the second term. And if that equals 0, right, there's 2 ways that could happen. You can have cosine 3x could equal 0, or this factor could equal 0. And so if you look at what that would do for you, that could be 4 cosine 3x plus 2 root 3 could equal 0. If you move the 2 root 3 over, and so we got 4 cos 3x equals minus 2 root 3, then you divide by 4, it's saying cos 3x is equal to negative root 3 over 2, right? You just cancel the 2's. Well, you're left with a 2, I guess, on the bottom when you divide by 4. So all that algebra just to get to the point where cos 3x equals 0 and cos 3x equals negative root 3 over 2. You should recognize that both of these are nice unit circle problems. This is something that we could do without we could do this without a calculator. It's one that's going to be nice. And now we just got to deal with this weird fact that we've got cosine of 3x instead of cosine of like x equals 0 or something. And it's basically a u sub, the way that we've done u subs back in like higher order polynomial stuff. So what I'm actually going to do is I'm going to need more room, so I'm going to erase everything here and then put these 2 equations up at the top. All right, so to solve something like this, we're basically just going to do u sub, because we can do, let's actually use, like, let's let theta equal 3x, okay? And then we're going to solve cosine theta equals 0, right? And if you just think of the unit circle, right? You should be thinking, like, what x value, in here, because cosine is the x value, where do you get an x value of 0? And so that's like up here at pi over 2, or down here at 3 pi over 2. So theta equals pi over 2 plus 2 pi n, or theta equals 3 pi over 2 plus 2 pi n. And then literally the way that you get the real answer is you just unsubstitute, right? And you put in, instead of theta, right, that would mean that 3x equals pi over 2 plus 2 pi n, or 3x equals, actually I need a little more room, 3x equals 3 pi over 2 plus 2 pi n. And then you literally just divide by 3. So x would equal pi over 6 plus 2 pi n over 3. And then x down here would equal 3 pi over 6, or I guess it's the same as pi over 2. Plus 2 pi over 3. And so literally any angle that fits this or this, you could times it by 3 and then take the cosine of it and you would get 0, right? So that's how that's why that kind of angle is an answer. And then you just do the same thing for this negative root 3 over 2 one. So let's just do the same thing. Let theta equal 3x. So we're basically thinking, okay, cosine of theta, when does that equal negative root 3 over 2? And so if you do the all students take calc thing, you can't be in the first or the fourth quadrant. And so your triangles have to be kind of in 2 or 3 there. And then I'm literally just going to think like the finger trick thing. So, cosine, you have square root of fingers above over 2. And so it's literally going to be like a 30-degree reference angle, or just a pi over 6. So this angle would be 5 pi over 6. And then if you go into the third quadrant, you need to go pi over 6 more than, pi. So that's 7 pi over 6. Okay. So then theta equals 5 pi over 6 plus 2 pi n. But again, theta is really 3x. So I'm going to just put that in right now. And then in that case, x would be 5 pi over 18 plus 2 pi n over 3. And then, I'm running out of room. I'm going to erase this. So the other one was 7 pi over 6. So 3x equals 7 pi over 6 plus 2 pi n. So then x would be divided by 3. You get 7 pi over 18 again, plus 2 pi n over 3. So any of those 4 kinds of answers would solve this one. And really, if you have any other multiple of an angle in here, you would just do the same kind of trick. You basically are just doing u sub so that you can get it to a thing like this that you know how to solve. And then you just unsubstitute, right? So theta is 3x, and then we just divide by the number. If it had been 5x, you would have divided by 5, and you get some other weird thing. I guess these could be, sometimes reduced a little bit. There might be some like redundancies between these two, but because you're doing 2 pi n over 3, and you could get this angle from adding some of those, but it doesn't really matter that you're saying a redundant answer. You're still saying that's an answer, so that's okay.